All right, everybody, here we are with part two of that 2020 set of problems from part one. Remember, we're not allowed to use a calculator on these. We got to do it the old-fashioned way, pencil to paper or pen to paper in this case, so you can see it a little more easily. We're just going to jump right in. Number 16, we're trying to select all correct answers. We saw a few problems like that in part one, where you really got to pay attention to the fact that there could be multiple correct answers. So we're trying to find the perimeter. We just got to add all of this stuff up. If you add these together, 493 centimeters plus 227 centimeters, you should have gotten 720 centimeters. And then when you add that same 720 from the other two sides, don't forget to add all the sides, we would have found out that B, 1,440 centimeters, is a correct answer. But if you know your conversions, you might remember that 100 centimeters equals 1 meter. So if we have about 1,400, that means that's about 14 meters. There's our other answer, C, 14 and 4/10 meters. Now with those powers of 10, another quick way you could have solved that, if it takes 100 of these, so it's like dividing it by 100 to get to 1 meter, you could also imagine that decimal right here and just scoot it 2 spots to the left, since we're dividing by 2 powers of 10 there, 10 to the second power. 1, 2, 14.40. Same thing as 14 and 4/10 there. So B and C would have worked out. As we move on now to number 17, they were nice enough to give us some formulas here on how to find the formula of, or the area of a triangle and a parallelogram. Don't worry about this. That 11 was marked out. They told us that was not the number they wanted us to use, so they had us change it that year. So they've given us the formulas, and it wants us to find the sum of the areas. So you always want to pay attention to those little extra questions, little extra pieces that they might put on there, one more step that we've got to do. So for the triangle, it's 1/2 the base times the height. So we've got the base here of 8, the height of 6. Remember, height always has to be straight up and down, not that diagonal side. So 6 times 8 is 48, but when I cut that in half, that gets me 24 square inches here on the triangle. For the parallelogram, it's pretty easy. It's just base times height. Now, some people got thrown off like, oh my gosh, they didn't give me the base. How am I supposed to find that? Well, a parallelogram is just kind of a leaning rectangle. So just like in a rectangle, the top and bottom are congruent and the left and right are congruent, same thing in a parallelogram. So that base down here is also going to be 8 inches times the 4 inches, base times height. So 8 times 4 gets us an area of 32 square inches, but it did say find the sum. So when we add those together, 24 plus 32, that gets us our final answer of 56 square inches. And now we move on to number 18. The box below was packed with cubes measuring 3 inches by 3 inches by 3 inches. The box was packed with no gaps. How many cubes were used to completely fill the box? Now, in a question like this, I could see them asking it with volume, and we'll actually see another problem like that here in just a moment. Or they might ask it with area, but the process for either one, area or volume, is 100% identical. Find the volume or area of the thing that's getting packed. Find the area or volume of the pieces that you're putting in there or the items that you're putting in there, and then you're just going to divide those to see how many would fit. So first, I've got to find the volume of this big one. The volume here is pretty easy. 3 times 3 times 3 would be 27 cubic inches. 3 times 3 is 9, times another 3 is 27 cubic inches. And then with this one, 15 times 9 times 6, here's a good mental math tip. Look for those friendly combinations. If I see a 15, 5, and 6, I know that's going to get me a 0 at the end, which will make multiplying by the 9 a little bit simpler. So 15 times 6 would be 90. And then 9 times 90 would get me 810 cubic inches. And as we've said before, the numbers are never accidental. If you know your powers of 3, you might have noticed, hey, wait a minute, that's kind of like 9 times 9. And 9 times 9, if I could break that down, would be the same as 3 times 3 times 3 times 3. So 4 threes, oh, look at that, 3 of them are right here. So another times 3 would get me 81. But then it's 810, 10 times more, so times 3 times 10, 30 of those cubes would fit. Because multiplying this by 3 gets me to 81, and then multiplying that by another 10, 3 times 10, gets me to the 810. You also could have just divided it out. If you did your 810 divided by 27, you should have gotten 30. You get the same answer. You just look for those little shortcuts that can save you a few moments. That extra time can be used on later problems. Number 19, told you we were going to see something similar here in just a moment. A box with a minimum of 540 cubic inches is needed to pack the trophies for a math contest, like the one that we're practicing for right now. Select all boxes that the trophies can be packed in. So really we just need to figure out the volumes and see, does this get me something that's greater than 540 or not, or at least equal to. Now the first one, I'm not going to multiply this out. I know you can do that. The first one, if you multiply it correctly, you should have gotten 512 cubic inches. That one's a no-go, not big enough. The second one, if we do the 15 times 6 is 90 times 6, that gets us exactly 540 cubic inches. So B is in play. That one can work. The letter C, I almost said number C, if you multiply those out, you get 504 cubic inches. Not big enough. And then here, 10 times 7 is 70, times 9 is 630 cubic inches. So that one is way more than we need. So B and D, there's that select all of them possible that there are multiple answers. B and D are going to work out for us there. On number 20, John is stacking a display of cans of Speedster, a new energy drink. John has 843 cans to display. Each row can hold 34 cans. How many rows will John stack to display all 843 cans? So what we're going to take a look at here is if we do the division, 843 divided by those 34 per row. If you go through and divide that out properly, you're going to get 24 remainder 27. Now that seems like a big remainder, but the rule of remainders is as long as it's less than the divisor, then it could be right. So that definitely fits, so we're okay here. Now here's where this problem's getting a little bit tricky. You've really got to understand the idea of what division means to understand what these numbers are trying to tell you. If we have 843 cans and we're putting 34 in each row, this answer tells me I have filled 24 rows. But I still have 27 cans that need to be displayed. That means he's going to need another row for these final 27. It just won't be a full complete row, but we're going to have a total of 25 rows. Now, a few different ways something like this might get asked at the contest. I could see them maybe changing up the wording on the question to say something like, how many full rows would there be? The answer here would be 24. Maybe it says something like, he only wants complete rows. How many cans would be left over and not displayed? Well, if that's how it's worded, then it would be the 27 that are left over. But on this one, if it's just how many rows to display all 843, we've got the 24 full rows, but we need that 25th row for the remaining cans. So we move on to number 21. This one is more just some number sense than actually finding a final answer. At the concession stand, a bag of popcorn costs $1.25. A drink costs $1.15. A candy bar costs $1.50. And oh my goodness, do I wish movie theater concessions had those prices right now. Select all expressions, multiple answers, that could be used to find the total cost for 4 people to buy a bag of popcorn, a drink, and a candy bar. So basically it's just, could this problem get you your final answer? So as we take a look at this, we look at A. Well, 4 times $1.25, there's 4 bags of popcorn, plus 4 times $1.15, there's your 4 drinks, plus 4 times $1.50, there's your 4 candy bars. That one works out just fine. As we look at B as a possibility, On this one, what they did was they added up each individual item, and if you add those, it does equal $3.90 that each of them are spending. And if 4 of them are doing that, this one would work. 4 times the total cost of all 3 items would get me an accurate total. On C, what they've done is first they added up all of the items, and then they're going to multiply that sum by 4. Now, for those of you really thinking, B and C are exactly the same. Because if you add these up, you're going to get that $3.90. And really, A is the same too. You'll learn about the distributive property later on in your lives, where you can multiply that 4 by each of the things inside the parentheses. But this definitely works. B is kind of a simplified version of C. On D, $1.25 plus 4 times $1.15 plus $1.50, well, that would be like 1 bag of popcorn, 1 candy bar, and 4 drinks. That one does not work. On E, 125 times 4, 115 times 4, and then $1.50. Well, that's 4 popcorns, 4 drinks, but only 1 candy bar. That does not fit the problem, so A, B, and C fit here. Number 22, we're kind of going back to those skills from the first couple of problems on the other video, questions 1 and 2, where we were trying to find fractions of another whole number. Mr. Fisher's math class is 48 minutes long. Mr. Fisher follows the same schedule each day. An eighth of the class reviewing, a third of the class presenting new material, a fourth of the class for questions, and the remaining time to get started on homework. And they want to know how many minutes are spent each class period on homework. So we're not looking for a fraction as a final answer. We're looking for a total number of minutes. So I'm going to take that 48-minute long class, and I'm going to see how many minutes do each of these really break down to. Well, 1/8 means divide it by 8 and keep one of those groups. 48 divided by 8 is 6. Keep one of those, so we've got 6 minutes here. 1/3 means break it into 3 groups and keep one of them. So 48 divided by 3 is 16. Keep one of those. There's another 16 minutes on new material. 1/4 of the time, divide this by 4 and keep one group. 48 divided by 4 is 12. I'm keeping one of those, so there's 12 minutes. And then when I go through and combine these, 6 plus 16 is 22. Plus the 12, all of this works out to 34 minutes. And so if the total class is 48, then the homework is all of the time remaining, 14 minutes remaining. And that's our answer for number 22. Just remember, when you're trying to find a fraction of any number, divide by the denominator, multiply by the numerator, and there's your fraction of that number. And don't forget what we talked about in one of our previous practice sessions. You can actually multiply first, then divide, but that just makes the division a little bit more of a pain in the butt because you've got bigger numbers to deal with. So if you divide by the denominator, then multiply by the numerator, it should work out a little bit more easily. As we flip over to number 23, it says, the Smith family plans to carpet their hallway to the back porch. The hallway measures 9 1/6 feet by 2 1/5 feet. Find the amount of carpet they need to order. Express your answer as a mixed number in simplest form. Well, if we're just trying to find the area here to cover a hallway, we've got to multiply these. So 9 1/6 times 2 1/5. And I think our best option here, and is often the best option when you're multiplying mixed numbers, is to turn those into improper fractions first. Now, when you add or subtract, I would typically recommend leaving them as mixed numbers. But for multiplying and dividing, changing them to improper fractions is probably going to be the easier play here. So to turn these into improper fractions, we take the denominator times the whole number and then add the numerator. So 6 times 9 is 54, plus 1 is 55/6. The denominator is not going to change on us here. And we're going to multiply that by 2 1/5, so 5 times 2 is 10. Plus 1 is 11/5. I've said multiple times, the numbers are never accidental. They are always chosen intentionally. And if you remember one of the skills that we talked about, there's a thing called cross-canceling when you are multiplying fractions, which means on the diagonal, we can divide both of these by the same thing. And look at that 55 and 5 sitting there for easy division. I can divide both of those by 5. That gets me 11 over here and 1 down here. And boy, does this simplify everything that I need to deal with. So from here, I've got 11 times 11, which I know is 121. You want to kind of know those square numbers. And then 6 times 1 is going to work out to just 6. So I've got 120 divided by 6. When you go through and figure all that out to turn it back into a mixed number, I get 20 and 1/6. And I've got my square feet. Now the biggest advantage of doing that cross-canceling when you are multiplying fractions is it often helps you get to the lowest terms right off the bat, or at least closer to lowest terms when you get done. So there's a lot of advantages to looking for that cross-canceling. Now the reason we didn't do it here with these two is there's nothing that 6 and 11 are both divisible by if we want it to work out equally. I could divide 6 by 2, 3, or 6, but none of those are going to work out evenly here. The only thing besides 11 that would work for this number, the numerator here, is a 1, and that's not going to help us out at all. So that's why we didn't do any cross-canceling there. Moving on to number 24. What is the perimeter of the regular pentagon shown below? Express the perimeter as a mixed number in simplest form. I tell you what, in middle school and high school, you are going to see stuff like simplest form or possibly lowest terms so many times. So many times. Now, I'd say you've got two plays here. You could do 2 and 7/10 and just add that up 5 different times. 2 and 7/10 plus 2 and 7/10 plus 2 and 7/10 plus 2 and 7/10 plus 2 and 7/10. Or a slightly faster way is let's multiply that by 5 because that's the same as that repeated addition. So if I take my 2 and 7/10 times 5, that will give me the perimeter. Now, you could convert this to an improper fraction, do 5 over 1 and do your multiplication and convert it back to a mixed number. But if I've just got a whole number times a mixed number, something that I like to do is kind of that partial products idea, and I like to break this mixed number down. I'm going to do 2 times 5, there's a 10, and then 7/10 times 5, which is the same as 5 over 1, so that gets me 35/10. Well, I can quickly convert that back to a mixed number way more easily than the bigger numbers if I did it all at once. That gets me 3 and 5/10, and that fraction jumps out to me very quickly as a 1/2, so there's 3 1/2. And then the 10 that I had here, I get my 13 1/2 centimeters. So I like breaking down my mixed number by a whole number multiplication into 2 slightly smaller problems. That works better for me. If turning this into an improper fraction of 27/10 times 5 over 1 makes more sense to you, it will absolutely still work out. Number 25, this is kind of that idea that we were talking about on a previous problem of how to find a fraction of a whole number, where you divide by the denominator and multiply by the numerator, and this is going to work out just the same way. Just because we've got an improper fraction, what number is 8/5 of the product of 39 and 10? For a short problem in terms of number of words, that could be pretty complex for some people. But let's just break this down into some smaller parts. So I've got to find this fraction of this product. Well, 39 times 10, because product is a multiplication answer, 39 times 10, that's not too bad, is 390. So I'm really finding 8/5 of 390. When you are finding a fraction of anything, divide by the denominator, then multiply by the numerator. So if I do 390 divided by 5, and you can go through and pause the video possibly and do the long division on your own. I don't think it's going to take you too terribly long. You should end up with 78. Because 350 divided by 5 would be 70, and then that other 40 divided by 5 would be 8. Then I divided by 5, so I know each group is worth 78, but now I need 8 of those groups. So 78 times 8, and here's that partial products idea again that can help you solve these problems mentally instead of showing every step. I know 70 times 8 would be 560, and 8 times 8 is a quick 64 off a basic fact, and then you should be able to add those fairly quickly and get your 624 as a final answer. So none of the individual steps here should be too bad if you just remember the process. If you're finding a fraction of a different number, divide by the denominator then multiply by the numerator. Number 26, we're getting fairly close to the end of this 2020 test, at least part 1. We'll have to come back for part 2 with some of those questions that we can use a calculator on. Honey Creek is hosting a bake sale for Riley Children's Hospital. Great organization, by the way. 7 pies have been donated. Each pie cut into sixths. So if you just want to kind of imagine what that might look like, I'm no artist, so pretend that's drawn a little bit evenly. And we've got those 1 pie gets us 6 slices. A slice of pie, so each of those slices, sells for $1.50. So if I'm multiplying that by that $1.50 per slice, that's $9 per pie. If all slices of pie are sold, how much money will be made from the pies? I did see some people figuring out how many slices there would be, and so they did the 6 times 7 equals 42, and then they multiplied that by $1.50, but that's going to be a little more complicated than it needs to be. 6 times $1.50 is going to be way easier than 42 times $1.50. And then we get $9 per pie times the 7 pies gets you your final answer of $63. Now, either way you do it, 42 slices times $1.50 or 7 pies times $9, you should get that $63 final answer. But if you have an option to break it into smaller parts, okay, I get this much for 1 pie, 7 pies, might make your multiplication a little bit easier. Number 27 is one that on the surface seems much more complicated than it really is. A dandelion grows 1/9 of an inch each day. How many days will it take for the dandelion to grow 3 2/3 inches? The big complicating factor here is that our denominators don't match, and we're comparing a regular fraction to a mixed number. So let's take care of that mixed number thing first and turn it into an improper fraction. Remember, denominator times the whole number, then add the numerator. So 3 times 3 is 9, plus the 2 gets me 11/3. Well, now I've still got the complicating factor of the denominators being different, but we can use equivalent fractions to fix that. If I want to get this to ninths, because that's the unit that I'm working with, I can multiply both of these by 3. That gets me 33 ninths. And now the problem should be as easy as that slice of pie from problem 26. If it has grown 33 ninths, and it's growing 1/9 each day, 33 days. Number 28. Often as you get later into the test, the problems become a little bit more complex and complicated, but this one, not too awful, fairly straightforward, just some decimal multiplication. A bus driver's route is a total of 4.7 or 4 7/10 kilometers each day. School is in session 182 days. How many kilometers does the bus driver drive in a school year? Well, this is just multiplying, as I said, so we've got 182 days times 4 7/10 each day. Remember, when you multiply, you do not have to get the place values matched up. You do when you add or subtract, not when you multiply. And if you go through and multiply this out and adjust for your decimal, you should have ended up at 855 4/10 kilometers. So just straightforward multiplying, get that decimal in the right spot, and you're good to go. Now we're going to jump past number 29 for a moment. I would say this one, because of the double variable situation, is probably the most complicated problem in this set of 30, so we're going to come back to that one last. Let's go ahead and jump to number 30, and then we'll use the space that we've got underneath to figure out how to solve number 29. It's a bit trickier. So in number 30, high temperatures were recorded for 11 days, and we've got that data here, and what I've already done is gone through and listed all of those temperatures in numerical order from least to greatest. Now, it doesn't have to be least to greatest. You can do it greatest to least. I'm just always in the habit of going from the smallest one first. And one thing you want to watch out for is if any temperatures are duplicated. For example, we had a 77 here, but a 77 again later in the data set. Make sure you list it twice because it happened 2 different times. So now we're just going to go through. We talked about these statistical landmarks, I think, in one of our first practices, either our first or second. And so we're just going to go through and see, are these true or not? So A, there is no mode. The mode is the most frequent. So if there is no mode, That means every number showed up an identical number of times. Well, almost all of these showed up once, but 77 showed up twice. That's more than the rest. That means there is a mode. So that's out. There is no median. Well, that literally can't be true of any data set. I don't even need to look at these numbers. If you're trying to tell me you've got a group of numbers and there's no median, that means you don't understand what a median is. There will always be something in the middle. So that one can't possibly be true. C, the median and the mode have the same value. Now we just said the mode was 77. That showed up twice. All the others only showed up once. So let's go ahead and figure out what the median is. Well, if I've got 11 numbers, right smack dab in the middle would be the sixth one, because then there would be 5 on either side. So 1, 2, 3, 4, 5, 6. And if you look, if I set that as my median, I've got 1, 2, 3, 4, 5 numbers greater, 1, 2, 3, 4, 5 numbers equal or lower. So that is my median, same amount on both sides. Don't forget from a previous practice, if by some chance you have an even number of things in your data set, and let's say these were the two in the middle, you just figure out what's exactly halfway between those. So like I said, there has to be a median of some kind. So the median is also 77, same value. C is something that works. D, the median is 77. Well, yeah, we just found that, so that works. The mode is 82 degrees. Nope, we already figured out the mode is 77. That one's out. C and D would be the correct answer here. Look at how many of these we were finding multiple answers. Always watch out for that. So now we're going to come back to this piece of work. Number 29. 10 members of a family decide to go bowling because they are awesome and cool people go bowling. In case you didn't know, I'm a big bowler. I'm a fan of this question. The number of children, represented by the variable C, and the number of adults with the variable A can be found using the equation $1.35 times C plus $2.50 times A. Don't ever forget, when you've got a number right next to a variable with nothing in between, it's always multiplication. And so they're telling us if the kids are getting charged $1.35 for a game, and the adults are getting charged $2.50 per game, and the grand total was $18.10, we're trying to figure out how many children were in the group, but we also at the same time have to figure out how many adults were in the group. Now the big complicating factor here is we've got dual unknowns, two different variables that we don't have really any clear indication of what those numbers should be. There's a few different ways that you can solve this. One way is guess and check. We know there's 10 people total, so you could just start plugging in some random numbers. You could say, okay, well, let's say there's 5 kids and 5 adults. So you could do $1.35 times 5, $2.50 times 5, see what your answer is, and adjust from there. Now that guess and check can be a good strategy. For something like this, though, that's probably going to take a little bit of time. So you want to make sure if you've only got a minute or two left, that may not be enough time to solve this one. I would only do a lot of guess and check if you've got plenty of time and you've already attempted the other problems on the test and you're just coming back to some of the trickier ones. Now I'm going to come down here and rewrite some of this information. So the children are $1.35 for the game. The adults are $2.50 for the game. And we know the total, that's not a plus sign, that's a T for total, was $18.10. Now I'm going to make myself a little chart here. And something that can be a really handy way to solve this, and we know there were 10 total people, so we don't need to worry about checking things like, well, what if it was 7 children and 19 adults? Well, that can't possibly be because there were only 10 people total. Something that I like to do is check the middle and check the extremes, which means what if it was only 10 kids and 0 adults? Well, 10 times $1.35 would be $13.50. Clearly too low. Well, what happens if it was all adults? 10 times $2.50 would be $25. Now here's where I find doing those extremes helpful. Because even though I'm almost certain neither one of them is going to be correct, it can help me figure out where to start guessing and checking. As I look, only kids was $13.50, a little more than $4.50 away. Only adults was $25. That's almost $7 away. So here's what that tells me. Only kids is closer to my real answer, which means there are going to be more kids, more children, than adults. So any possibility where it's even 5 and 5 or more adults, I know I don't need to check any of those. So I could maybe start, all right, I know there have to be more children, so if 5 and 5 doesn't work, so maybe I start with 6 children, 4 adults. And if you work those values out, 4 adults is going to be exactly $10. And then 6 kids, well, $6 times the 30 cents, $1.80, so there's $7.80. And then 5 times 6, there's another 30 cents. That's $8.10 plus the $10 here. And look at that. I've got my answer. And then it wanted to know the number of children. So there we go. 6 children. Now let's say that this didn't work out. I did my extremes, only kids, only adults. I figured out the kids are closer, so that means there's more of them. And I did my first guess and check at 6 and 4, and it wasn't correct. Well, you just adjust. Let's say we guessed 6 kids, and our answer ended up too high. Well, that means I need more kids, because the adults are getting charged more, so I got to bring that cost down. If I guess 6 kids, and my answer is too low, well, remember, all kids got me too low of an answer. So if my answer is still too low, that means I need more adults. So we can use our guess and check plus our logic skills to adjust and guess reasonably and logically. It's not just random blind numbers that we're pulling out of nowhere. We can put some logic into that. Now, if you are still confused about how I did this chart and how that goes back to solving this, that's okay. This is a very challenging problem, and we will definitely see some others like this on other practice questions that we go through, so we'll definitely have an opportunity to practice that some more. But for now, we have reached the end of our first 30 questions. That wraps up part 1 of the 2020 test. We'll have another video in the very near future where we take a look at the 8 questions from part 2, where we do get to use a calculator, although that doesn't always mean we need to. We'll talk about that with that video. So thanks for watching our 16 through 30, and I hope you've learned a lot.